Welcome to a new In the Mail. Let's get right into it with this set of test clips. These are the grabbing type hooks, the ones you would use on your logic analyzer, for example. The set contains 10 pieces, 5 are red and 5 are black, and they should be good for other purposes as well, but only up to 60 volts and 1 amp. They're not the soldering type. You can't solder wires to their connections, but instead they accept these DuPont female headers. So you can connect it like this. And you get a dual connection on each of these hooks. So you can connect two things to one of these grabbing hooks. Here is a close-up of how these work and an example of a use case scenario where I probe a single pin of that SMD package. The set was something like $9 with free shipping. It appears to be manufactured or sold under the name of Denu, the same as the probe set I showed in a previous video. I'm pretty sure this will be useful in the lab, and don't forget, links for all the products shown in this video will be posted in the description below. Our next item is an isolated AC to DC converter, which supposedly will output 5 volts at 2.4 amps, which I find hard to believe in such a small package. Since it's all potted, we're not going to be able to see what its hardware looks like inside, but I think it uses a switching converter, maybe a flyback topology. I couldn't find any datasheet to verify this, but I'm guessing they left out the input and output filtering to save space. And I also saw this board being sold on AliExpress, which has all the input filtering and protection as well as output filtering built around this module on a PCB. So let's give this module a test and put a scope on the output and see how the waveform looks like. It seems the high voltage input is on this side where the pins are closer together, which is counterintuitive. You would want the high voltage pins spaced further apart, right? But anyway, the output is on the right side. I'm going to plug it in without connecting the scope, just in case anything blows up. I don't want to damage my scope, but it seems everything is fine. Let's also bring in a multimeter to measure the output voltage. Okay, so we are getting our 5 volts on the output, and it seems the voltage is pretty accurate, 5.01 volts. We'll see how the regulation is later when we connect a dummy load. But first I want to take a look at the output noise, and for that I'm going to connect the oscilloscope. So this is our base measurement, the background noise, and right now I'm going to connect the probe. This is the noise we are getting on the output of this converter. I'm sorry, but I'm holding the probe with my hand and sometimes I lose the signal, but we're seeing approximately 400, maybe even more than 400 millivolts peak-to-peak noise. So it's a pretty noisy converter. I'm pretty sure it doesn't have the required filtering elements inside this module, so those need to be added externally. We can always add external filtering to this module, but what I'm mostly interested is to see if it can really output 2.4 amps at 5 volts, and for that I'm going to use my dummy load. So let's get started at half an amp. I'm using this red plastic filter to increase the contrast on these 7-segment displays. Let's go up to 1 amp. I'm hearing a hiss from the converter. So it dropped to 4.9 volts. But who knows, maybe with some added capacitance on the output it would perform better. It's really hissing at 1.5 amps. Let me just add a capacitor on the output to see if the behavior improves. Okay, so I have added a 1000 microfarad capacitor on the output. Let's try again. So you see a much better behavior. I don't hear the hiss anymore at 1.5 amps, and the voltage is exactly 5 volts on the output. So it really needs external components to function properly. Let's go up to 2 amps. Yeah, now it's looking like it can do 2.4 amps. So you see at 2.4 amps we're seeing basically 4.99 volts on the output, which is excellent regulation. It can really do the spec output at 2.4 amps. I'm not sure about the temperature of the module, if it will get hot or not. Let's try to measure that. So I'm reading close to 60 degrees Celsius on the module, so things are getting pretty hot inside. It might need some heat sinking or some airflow to work at the full rated power for longer periods of time. So this module sells for around $6, and it might be worth getting one of these to use as a power supply in a project. It has the advantage of being very compact. My next item is one of these tripod clamp things for a camera. It has these extending arms in here which turn it into a tripod, and it also has the clamp on the side, so you can clamp it to pretty much anything, a thick tabletop, a pipe, a support pipe. Kind of like the design. It should be useful in here in the lab, hanging an additional light on the bench when shooting video, or maybe an additional camera. There is always a good use for something like this when you're shooting video. And it has the usual what is it, 3/4 mount for that every camera has. Next, I have one of these round aluminium substrate PCBs. This is designed to take 9 LEDs, so you could solder 9 white LEDs to this board, which have a typical forward voltage of 3.7 volts, and you get a total voltage of 33.3 volts, because all of these will be in series. And if we look closely at the board, we can see the copper plates connecting the LEDs together in series, and you get these contact points in here. You run the wire through this hole and you get yourself a ring light. I'm not sure about the light distribution. I think the light distribution is better with one of these ring lights, which has more individual LEDs. You'll probably get a more even light distribution with one of these, but you definitely get more output power with these 1 watt LEDs. You will of course also need to stick this to a heatsink. Just the PCB itself will not dissipate all the heat created by the 1 watt LEDs, especially if you run them at full brightness. This can also be used as a macro shooting light or microscope light, but having just those 9 LEDs might create uneven light distribution, so you might need to use some kind of diffusion layer in front of it. Next up, I have this 10 watt plant growing LED, and I know what you guys are all thinking. This guy is starting a marijuana plantation, but that's not the case. I saw these kind of LEDs in pictures and videos, and they looked rather nice with their pink color, so I decided to get one just to check it out. And I'm going to power this one just to show you how it looks. Here it is at a very low current. Let's drop the current even more to be able to see the individual dies. And although it's not very visible on video, the outer LEDs, the ones on the left and the right side, are the red LEDs, and the ones in the middle are the blue LEDs. So there you go, I dropped the voltage right down for that to be visible, because as soon as I increase the voltage or the current, the colors mix and it gets this rather nice pink color. So like I mentioned, 9 individual LED dies in there, and because there's 6 red and 3 blues, the driving voltage is between 9 and 11 volts at 1 amp. I don't think it's very healthy for your eyes to look into something like this bright. so I'm not sure what I'm going to use it for. I don't think it's good for other than for growing plants, but like I said, I just wanted to check it out, and it was inexpensive, something like $3. It's interesting that you can buy something like this with different colored LEDs inside the die. Don't forget, this will also need a heatsink. So here is an example aluminum heatsink that you might use for a 10-watt LED. This one is rather thin, and but I like the round shape. It's kind of perfect to hold this 10-watt LED, and maybe place a cooling fan on the back just to help keep things cool if you run the LED at full brightness. I think it's the perfect size. I have other 10-watt white LEDs, and I had no heatsink to stick them on, so I bought one of these to see how it works, and maybe I'll get more if they're okay. They're fairly inexpensive at $3.50 shipped, and as always, a link will be provided in the description below. I also got a couple of these smaller aluminum heatsinks. They're 10 by 4 centimeters and about 8 millimeters in thickness. You can get 2 of these for just $3 shipped. Once again, very cheap, and you can use these to maybe cool a Class D amplifier or a bank of MOSFETs on a PCB, a bunch of LDOs, whatever you want. I just like to keep a good selection of heatsinks in my heatsink box, and when I need one, I'm sure I'll find something which is the correct size for that particular project. This is a protection film for the screen of my ISDT Q6 LiPo charger, because it's made of acrylic or something similar that scratches very easily, and as you can see, it's already full of fine scratches. So I got a set of these protection films to prevent it from getting scratched, but unfortunately it's a bit too late now, because the charger is already scratched. I believe that when you design something like this with easily scratchable screen, you should include a protection film inside the box, because it's not a question about the price. The cost is like $1 for a piece of a protection film, but once you realize you got no protection and it scratches easily, it's already too late. You have to wait another 2 weeks for these to arrive from China, and in the meantime the screen on this is already pretty scratched. Next, I have a couple of LM1875 Class B amplifier kits. Let's see what we get inside the bag, because I see some instructions in here. The PCB looks to be of good quality. Let's check out the instructions. I'm pretty sure they're in Chinese, and yeah. But at least we get a picture of how it should look assembled. You also get a schematic of the circuit, which is pretty nice. This chip is capable of 20 watts mono output, so that's why I got 2 of them to create a stereo amplifier. These are not as efficient as the modern Class D amplifiers, but they should output a higher quality sound from their Class B topology. They have quite a wide supply range, from 16 to 60 volts, so that makes them ideal to be powered from all the laptop power bricks, which usually have a 20 volts output with at least a couple of amps. Not sure what I'll do with this, but I have a bunch of Class D amplifiers while I had none of the Class B, and it's always nice to know your amplifier chips, and what better way to learn about them than by building a kit and assessing the quality that you get out of these chips. Next, I have a couple of serial to USB adapters. I was running low on these. Sometimes they accidentally catch fire, some I just sacrifice and leave in some projects. So I got these 2. One of them is based on the FTDI chip. Obviously a clone, not a genuine chip, but it's the classical breakout for the FT232 from FTDI. and this other one is based on the chip from Silabs, and should be the CP21 or 2 or something similar if I remember correctly. Let's see if we can read the numbers of this. So yeah, it's the CP2102. I'm not sure if they're also clones of the Silab chips or if it's the genuine one. Not really sure, but it doesn't matter to me. It works and it does the job. Everyone should be familiar with these modules, and everyone should keep one or two in stock, because you use them in almost every project that needs serial communications. They also come in various shapes and forms. Some are 3.3 volts, some are 5 volts, some you can switch between. There are also the ones based on CH340, the Chinese chip, so lots to choose from. I think I have them all. This is a roll of electrical tape, but it's the kind that has this cloth, or how would you call this type of material? I think it's called cloth tape, and it's usually used in the automotive industry for wiring harnesses. Like if you look into your car, you will certainly find cable looms wrapped in this kind of tape. I think it's fire retardant, or at least it should be. And one of the advantages of using this kind of tape is that it will minimize any kind of rattling noise, because it's a soft material, very soft when compared to PVC, for example, which is rigid, and it makes that it gives you that plastic feeling. This kind of tape should be superior to PVC tape, also because of increased strength and abrasion resistance. So it should be better in any way. That's why it's used in the industry a lot. I paid like $2 for this 10-meter roll, which is not bad. This should last me a while. I don't use a lot of this stuff. But check out the link in the description if you're interested in something like this. My next item is this very small shock sensor. It's the 801S model number. As you can see, it has some nice what looks like gold-plated contacts on the end, and it makes a small rattling noise inside. It could be a spring or ball mechanism, I'm not sure, but this guy is very, very sensitive, and I'm going to show you that by connecting it to my multimeter on the ohms range, and you'll see we're going to look at the bar graph, because the bar graph updates very quickly. And I'm just slightly going to tap the table. You see how it goes over range, and if I tap with the slightest touch this bench, you'll see how it responds on the multimeter. So extremely sensitive sensor, and usually you can also buy it with a module that contains everything you need on board. But this is the usual schematic where you connect the sensor and you use it this way with a comparator to get a usable output signal from this sensor. So pretty interesting and inexpensive way of measuring very small shocks or vibrations. And my last item in today's video is this set of 200 pieces Grub screw assortment kit. If we look closely, they range from M3 up to M8, and in length they range from 3mm up to 10mm. It's nice to have one of these kits, because you might find yourself in a situation where you lost the Grub screw from a motor shaft or a banana jack, and you don't want to have to wait a couple of weeks for that screw to be delivered from China. So it's nice to have this kit. You can go to it and just use a replacement Grub screw and fix your problem. It's under $5 to get one of these kits delivered. At least for me, it's worth ordering one, even though I don't have an immediate application for this. It will just go next to the other assortment kits that I have, and I'm sure they will be very useful during a repair or something like that. This was all for today. I hope you found at least one interesting item to fuel the addiction for ordering these cheap parts from China. Thank you for watching. Don't forget to hit the like button and I will see you next time.